did the other day, I want you to look at your worksheet. So take out that worksheet that we're kind of putzing through. This one right here. And yours said epsilon, mine says tolerance. Agreed? Okay. And so who could tell me what the function is? What's the function? Yeah, f of x is equal to x squared minus 1. Everybody good? What does that look like? Parabola shifted down 1. Okay, so we'll go down 1. Great. What is the a value that we're approaching? We're approaching 2. What is the actual limit? Three. How'd you get 3? 2 squared is 4 minus 1 is 3. Because it says x is going to 2. Okay, so we're trying to peel off the cobwebs today to make it make a little bit more sense. Everybody clear with how I came up with the picture? Do you know where I came with 2? Came with 2 from there. I got 3 by plugging 2 in. Everybody good? So the deal is in order to prove that limits exist, the idea is I give you an epsilon and then we find a delta. For any epsilon that you're given, we just find a delta. So what is the epsilon in the first example? 0.1. So epsilon is the y value of our window. So we're going to go all the way up to what? 3.1, and I go all the way down to 2.9. And we're just going to do the first example and not the second example. Sometimes people worry about like their graph. You know, it's like, oh, it looks so messy and whatnot. Don't worry. Just try to figure out which side of 2 you're landing on. Okay? We all okay there? So 2.9 and 3.1. So I want to find an x value that corresponds. Who could tell me the equation I set up to find the x value that corresponds? Okay, x squared minus 1 is equal to 2.9. And x squared minus 1 is equal to 3.1. How do I solve? Yep, so x squared is equal to 3.9. Somebody square root, give me 3 decimal places on that. Somebody with a calculator, because mine is 1.974. 75. So that spot right there is 1.975. Okay, and then for the other one, we have x squared is equal to 4.1. So that should be a value a little bit above 2. So 2.025. Okay. So true or false? Delta is 1.975. False. Delta is the distance from 2 to 1.975 or from 2 to 2.025. So we technically take the smaller one. We could carry out the decimals to actually see which one is smaller, but for the sake of this class right now, can we just say that delta is equal to 0.025? Yeah. Okay, and so we can have pretty high confidence that that limit is exactly 3. Okay, does everybody agree that if I would choose an epsilon value of 0.01, I would still come up with a delta? Yeah, and as long as you continue to come up with a delta, then you're good to go. Okay, flip to this worksheet right here. Okay. In this example right here, how the question is how close, so it's just framed slightly differently, how close to 2 do we have to take x so that 5x plus 3 is within a distance of 0.01 from 13? Looks a lot different, doesn't it? I want you to take these pieces and see if you can plug them in. One of these values up there is a, one of them is f of x, one of them is L, and one is epsilon. Take 30 seconds on your own or with a partner and see if you can figure out which numbers go where. Okay? Go. Talk. Five, four, three, two, one, and here we go. This is the limit as x approaches what? Of 2. Excellent. How close to 2 do we have to get? Good. The 2 goes there. What's the function? 5x plus 3. What's the limit? The limit is 13. How can I confirm that the limit is in fact 13?
Because it says so that 5x plus 3 is within a distance of 0.1 from 13.
Yeah, from 13. And if you plug in 2, 5 times 2 is 10 plus 3 is, see that? And the epsilon value is 0.1. So we're not going to carry this problem all the way through. I'm not going to assign all this for homework, but let's just try to understand if 13 is the limit. Okay, if 13 is the limit, then what's my top and what's my bottom? 13.01. What's the bottom? So you would set up two equations. 5x plus 3 is equal to 13.01, and 5x plus 3 is equal to 12.99. Everybody agreed? And would we then be able to find a delta?
Yes.
Yeah. So we could do that all, day long, right? I mean, kind of have that idea. The idea is let's find our epsilon, move up and down, and then let's find a delta, right? So sometimes the question, and it's possible we could get this type of thing in the AP exam, which we would have to review, but sometimes it comes in this nature right here. So let's write this out in that language right there. The absolute value of, what is f of x? 5x plus 3 minus 13 is less than 0.01 when what minus what? X minus 2 is less than delta. And so the idea is we could come up with a delta, couldn't we? Given an epsilon, can you find a delta? It's the same question. It just looks different. So let's try that. Look at number 3. It says use the graph of 1 over x to find a number delta such that 1 over x minus 0.5 is less than 0.2 when x minus 2 is less than delta. So don't look at the graph yet. Here's what I want you to write. I want you to write the limit as x goes to a of f of x is equal to L and what epsilon is equal to. We always come back to this. See if you can figure out what this should be given this information. Figure out what this should be given this information. Go ahead. See if you can plug and play. Talk it through. Go. And pause. Let's see where you're at. Okay? Limit as x approaches what? 2. What's the function? 1 over x. What's the limit? 0.5. And what is epsilon? 0.2. Any confusion how we came up with any of those values? Okay, hey, right here. Right here. Look at this definition. Absolute value of f of x minus L is less than epsilon. From right here, you see that? So see how the epsilon is right there? That means that 0.2 is epsilon. See how it's in the same spot? Okay, so look at what they got, boys, right up here. Okay, it looks like they've chosen the 0.2. They went up 0.2 and they went down 0.2, and it looks like they've actually found the x values for us, haven't they? So we want to find the delta value. Delta is the difference between these two. Okay, so I'm going to figure out what's the distance between 10/3 and 2. So I would take 10/3 minus. I'm gonna do this one first, and I'm gonna do that one next. 10/3 minus, and I'm gonna do 6/3. So I'm gonna subtract 2, and what do I get? Yep. And then I take, let's see, 2 would be 14/7. I'm going to subtract 10/7, and I get 4/7. Which one's bigger? Which one's smaller? Yep, bigger is 4/3, smaller is 4/7. Okay. Yep. What's that? So I did 10/3 minus 2 to figure out that distance, and then I did 2 minus 10/7. Yeah. So they're only the same when you have a linear function. If you don't have a linear, they're going to be different. Yep. Yep. Flip it over. You do the same thing. Okay, I would like you to write the statement, limit as x approaches a of f of x is equal to L. Tell me what epsilon is using this information right there. And then go ahead and figure out what my two delta values are. Go ahead, take 2 minutes with your friends. Try to see what you could come up with for Okay, limit as x approaches what? 5. Good, you got your a value right there. Of the function, what's the function? F of x is equal to 3, and the epsilon value is 0.2. They've already found the x values for you. They are 4 and 5.7. What's the distance from 4 to 5? And what's the distance from 5 to 5.7? 0.7. Excellent, good job. Get the idea? Okay, good work. We could continue to do that over and over again, right? We don't need to do it over and over again. We'll do our last piece. Flip back to your notes. It is not the kind of geometry proof. It's actually, people tend to really like this. So we'll show you what it looks like. First of all, you're going to write down this. Absolute value of f of x minus, anybody remember what comes next?
Minus
L is less than epsilon. Whenever x minus a is less than delta. So you can see that after just a little bit of time and being very confused on Friday, you guys have begun to understand a little bit of where those pieces come from, right? So with our proof, there are 2 steps. And the first step is, 1, find an appropriate delta. So notice that in our work, we have consistently, when we're given an epsilon, we find a delta, right? That's what we've been doing over and over and over again, is finding a delta. Na 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 na. Phenomena. 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 Everybody know the Phenomena song? Yeah. Phenomena. All right. So, here's what we do. Okay? We start by writing down what we have. You are fully capable of doing this. What do I put in for f of x? Look at how good you are. Minus 13. Is less than epsilon. Okay? Whenever x minus 2 Anybody lost yet? We're all okay, right? Watch how cool this is. Okay, this is, to me, this is really gets pretty cool right here. Okay, watch this. Okay, we actually want to make this left thing look like the right thing. Okay, watch. It actually works out really well. Folks, if I want to simplify this a little bit, what's 3x plus 7 minus 13? Everybody okay with that? What could you factor out of 3x minus 6? Does everybody see how that actually looks a little bit more similar to that? And if I divide both sides by, I get the absolute value of x minus 2 is less than epsilon over 3. In fact, don't worry. In fact, if you look at this, like the epsilon over 3, that looks like in the same spot as the delta, doesn't it? So you may want to guess what we should choose for our delta. Epsilon over 3. Okay? So for example, suppose epsilon was 6, what should delta be? 2. Suppose epsilon was 30, delta should be? Suppose epsilon was 0.3, delta should be? So what this is saying is, whatever you choose for epsilon, we can make sure that you choose an appropriate delta. Just divide it by 3 and you're going to be good to go. You're going to be able to zoom in on that space and ensure that no matter what, that limit exists. So we say choose delta equal to epsilon over 3. So that we could choose the appropriate delta. So we made them look alike so we could choose the appropriate delta. Okay. Yep. And I'm gonna make one more note here. Okay. One more note here that's really important. Okay. No, we'll do that in a second. I don't want that to confuse anybody. Okay. Step number 2. Okay, we'll get to the and statement here in a second. Number 2. So this is the last part of the proof. We made one part look like that. Now, show the absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. Okay, because this is the important teaching point that I have to show you, okay? So we want to show that that is less than epsilon, okay? So watch what I'm going to do here. I'm going to start by making the blue statement. What is f of x? Minus what is L? You all good with that? Now, I would like to make the statement of less than, but I can't yet. Because I really don't have anything to compare it to that I've written down so far. But I do know this is equal to something. This is the same as what? What can this be simplified to? 3x minus 6. Okay with that? And that's the same as 3 times x minus 2. Good. Shh. Watch. Okay. So this is the key. Okay. So far I'm only working with this piece. Do you see that here? I would like to make the less than statement, which comes right here. But I'm gonna do something that is just kind of the one trick you have to see. If the absolute value of x minus 2 is less than delta, would everybody agree that 3 times the absolute value of x minus 2 is less than 3 delta? I just multiply both sides by 3. So I'm going to use that little piece of logic right here. Look at what I have. 3 absolute value of x minus 2. And what can I write after that? Less than 3 delta, right? So I've just used up my green piece. So look at what I've stated so far in my proof. I have this absolute value thing here. I have the less than sign right here. What is the last thing I need in my proof? I need an epsilon, okay? Well, 3 times delta, okay? Well, equals 3 times, what is delta? What did we choose delta to be? We chose delta to be epsilon over 3. And what is 3 times epsilon over 3?
All I see is 3 times.
It's epsilon. That means you're done with the proof. What? The epsilon here? What's 3 times epsilon over 3? Just epsilon, right? Yeah.
Why don't we just do that equals this? And then just say that delta equals this without having to.
You know, it's just not as convincing of an argument. You know, this is the piece that needs to come through. What I'd like you to do, okay, go to your worksheet. Shh. We have some time. What I would like to do is I'd like to move away from this tomorrow, okay? I would like you guys to try setting up this proof. And the first thing that you need to do is you need to start by, number 1, choose appropriate delta. Okay? I will help you guys get set up. Absolute value of what? 2x plus 3 minus 5 is less than epsilon whenever x minus 1 is less than delta. Go ahead and see if you can set up the first part, finding an appropriate delta. Go. Okay, I saw 4 groups had it. You have 2x what? Minus 2 less than epsilon. Factor out the x minus 1 is less than epsilon. So the absolute value of x minus 1 is less than what? Epsilon over 2. So does that look like that? Yeah, it's just instead of a delta, there's a epsilon over 2. So we choose delta equal to what? Epsilon over 2. So now you go ahead, show, this is second part right here, show the absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. I will give you a hint where to start. What is our first thing that we start with? 2x plus 3 minus 5, okay, that absolute value. And what is the thing that you have to end with? Epsilon. See if you can fill in the rest. See what you come up with. Go. Okay, I'm going to grab Maddie's sheet because she's got it perfect. She's done with it. So I'm going to go equals, you guys tell me what I put next. Absolute value of minus 2 equals. Okay, so that looks very similar to that, doesn't it? But it's not the same because it has a 2. So if I just go 2 times the absolute value of x minus 1 is less than 2 delta. So now what do I put in this place? Less than 2 delta. And instead of delta, what do I put in that place? That's exactly it. Sometimes a box is just, I'm done. Whatever.
Okay, so like on my homework, can I just
Sure.
read a box?
Sure.
I'm done. If I don't want to do a problem, I'm needing to read a box, and I hope you know that I'm done. Perfect.
Shh. Okay. So, trying to understand this idea and putting in bigger context. What does this say to us? Okay, boys, up here. Okay, this is actually less than 2.4. 2.3 was limits. This is kind of the proof of limits, and then 2.5. What that was continuity. And so here's the idea. In order to say that a function is continuous, which is pretty important, right? In order to actually say a function is continuous, you have to be able to prove that the limit exists for every single x value on that function. And here's the deal. As we move forward, as you guys went to 2.6, you find those slopes like we did. In order for us to be able to say anything about calculus, there's 2 things that have to be said. Number 1, we cannot really work with functions that are not continuous. We must have continuous functions. That is a piece of groundwork that may not seem like a big deal to you, but for 1,800 years, mathematics kind of stood still in the realm of calculus because they did not have the ideas that we just put forth now. Math doesn't just move on if we can't show something. It requires proof and conjecture. And the second thing, a function also must be what we call differentiable. And we will talk about what that means later on in this unit as well. But those are the 2 pieces. So, tomorrow we are ready to move on to the rest of calculus. You can take this and, if you want to put it on your fridge at home, if you want to, you got all sorts of options. No homework. You guys have homecoming. We're definitely going to have some homework, but I thought this would be a nice way to start things off.